This is lesson 6, and the topics for this lesson are going to be SasPlanet, how to make a cartography with Quantum GIS. Also, we are going to be talking about Alberta Tier 1 and Tier 2 soils and groundwater remediation guidelines. For the things we are going to do with Quantum GIS are going to be create a layer, new shapefile. Also, we are going to use the tool called snapping options. Then we're going to work with an attribute table edition, also for style and categorize some features, export features from one shapefile to a new shapefile. Also, we are going to be using a new geoprocessing tool called fixed distance buffer, and at the end we are going to add a new web map server WMS layer, but we are going to explain a lot of things about this kind of stuff in lesson 8, and in this lesson is going to be just a little bit, okay? The website we are going to visit today is going to be Alberta Water Walls. Hello guys, today we are going to do a cartography. I selected an area that has different kind of soils. First, let's go to download satellite imagery. We was working the other day in SasPlanet software. Now you know how to use it. First, let's go to rectangle selection. I want an area. Well, first of all, cancel. Let's go to put the zoom here. I want 20. If you put here 20, that's a lot. Zoom a lot, right? That's the resolution you are going to get the image if you put zoom 20. Let's go to make disappear all the black rectangles, making zoom. From here, all this one. Okay, I'm going to leave like this one. That's enough. Zoom 20 we set. Here, zoom 20. In GeoTIFF, I'm going to keep this one in the folder for lesson 6. I'm going to call the bone 3. Save. The map is going to be ArcGIS imagery here, the same as this one. No overlay layers, not these ones. Projection is going to be geographic WGS 84. Zoom 20, and that's it. Start. Okay, we have the satellite picture already. Is this one? Let's go to open Quantum GIS. Okay, now select the project properties. We are working in zone 12, and I'm going to select this kind of coordinate reference systems, WGS 84 UTM zone 12 north. Okay, sorry. I'm going to add the image. Its folder lesson 6 is this one. Open. That's projected already in UTM coordinates. Now we are going to start the cartography. We are going to create a new layer. Create layer. This layer is going to be a new shapefile. It's going to be polygon. The coordinate systems is going to be WGS 84 UTM zone 12 north. File encoding, I'm going to leave a system. Name field, it doesn't matter. Well, I'm going to put, it doesn't matter, this one. Well, soils. And the other ones are okay. Okay, the name of the file is going to be, we're going to keep in folder lesson 6. The name is going to be Carto, because we are going to do a cartography. Save as a shape. Okay. In order to start the vision of this layer, this new layer, we have to click here the pencil and select here, but first we have to do some modifications at the settings, snapping options. We have to go to advanced, select the layer, Carto is this layer, then select here, avoid intersections. That is going to make easy the cartography. For the features we are going to create, first let's go to create this area here. Just click, follow the perimeter. I'm not going to be very accurate because this one is just an example, okay? This area is going to be a residential area. Click right to finish. I'm going to put number 1, okay? Now I'm going to create the oil and gas area. Click. That one is going to be number 2. Number 3 is going to be this area here. That one is going to be agricultural area. That is an example. I don't know if this kind of soil for real it's an agricultural one. You know, I didn't check that information. It's just only an example. This is not a real case. I choose this location because it has a lot of different kind of scenarios, and I need to choose this one, right? But that's not a real case. It's just an example, okay? I'm going to do this area. As we made these options in the snapping options, you know, the advanced one, we click here, avoid intersections. We can make the points on the top of this layer. It doesn't matter because as we click that option, it's not going to be intersections between the features, okay? You are going to see better when I finish this layer, okay? Then I'm going to follow approximately the line of the trees. I'm not very accurate, but as I said, it's not the goal of this exercise to be really accurate. It's just an example to how to do a cartography. Here. Then we are going to edit the layer. Now here, or even more here, and here. Now I'm going to finish. Click right, and you are going to see how this area is not going to be the limit for this feature. The limit is going to be the one with it. I'm going to show you. Click right. Number 3 for this one. You see what is the limit? Now I am going to do the also this residential area here. Okay, we have all the map already with features. Then let's go to finish the edition, clicking this button here. Save. Now we are going to add a new field at the attribute table. Then start edition again. New field, this button here, click. The name is going to be soil type. No comments. Type is going to be text. Length is going to be 80 characters. Okay. Now when you click here, number 1, you are going to be on the map selected. Is this one? That one is a residential one. For the next one, this one, it's the oil and gas. The third one is going to be agricultural. Number 4 is going to be residential. Number 5 is going to be forest. Number 6 is going to be the river. Number 7 is going to be also oil and gas. You have to make sure you put the same name. Residential also, because after that we are going to classify all the features. Okay, then after that finish the edition, clicking on the pencil, save. Okay, now we can close this one, go to properties. Here at the top, in style, we have to go to Categorize, add. Oh, sorry. First, what I have to do, I'm going to eliminate this one. Here are the column, select soil type, classify. As you can see now, for every kind of feature we have different colors. Okay, apply. As apply, you are going to see on the map. Okay, then for example we can edit these colors. For the agricultural one, I'm going to use a green one. For example, this one. Oh, it doesn't apply. Now change. For the forest, I'm going to use a dark green, for example. As you can see now on the map, we have different colors for every feature. For example, for agricultural, we have the brown one. Okay, for the forest we have the green one. For residential we have the lilac. For the river we have a blue one. Okay, and now what I'm going to do is create a new layer, but first I'm going to add the flow map going to apply transparency. And I'm going to do the cartography of this polygon here for the float area. Okay. To do that one, first we have to create a new layer. Create layer, new shapefile layer, polygon. The file encoding is going to be system, and the coordinate systems is going to be WGS 84 UTM zone 12 north. That's okay. The name is going to be float. For the type, text data, that's okay. The length 80 characters, that's good. Okay. We are going to save the file as a float for the shapefile. Now, before to start the edition, we are going to go to snap options. Okay, let's go to remove this option here to avoid any conflict with the other layers. Then go here, click the pencil, and we are ready to edit the float area. Just follow this contour line. Okay, we have already the edition. Then let's go to finish, save. We can take out this layer here. That's the float area. We can change the color for our blue one. Now we are going to export a couple of features. It's going to be the residential areas. Then go here, properties. Attribute table. Open the attribute table. Let's go to select these two. It's going to be the residential, this one and this one. Okay. In order to select two features, you have to press the shift button on the keyboard and then select. Now go here, click right, save as, save only selected features. Okay. We are going to keep here, we are going to put the name for the new shapefile, residential. Save. Just save only selected features. Okay. The coordinates is going to be this one, that's okay. And the rest is okay. Make sure you have a shapefile selected for the format. Okay. Okay, and now if we take this layer out, as you can see, we have these couple features here. And now we are going to do a buffer analysis. Okay, first of all, we are going to start with the buffer of the residential areas. Okay, for that one, just go vector, geoprocessing. There are a couple of buffer analysis we can apply. There is a variable distance buffer and fixed distance buffer. We are going to use the second one. Double click. Then the input layer is going to be the residential one, is the shapefile we created. Okay. Then the buffer distance is going to be 30 meters, because as you can see in the tier 1, the 30 meters buffer is for the more sensitive land use. Okay, the segment here is going to be 5 run. Then now we have the buffer. Let's go to move the residential to the top a little bit. Okay, now let's go to see the distance. Okay, here you are going to see the distance in meters. Then, for example, this one is the residential area, and this one is agricultural, as we did at the cartography, the yellow one. Okay. Now, if you click here, from here to here, you're going to see there 30 meters. Okay. Close. Now we have all this area. It's a 30 meters buffer. Okay. For example, if we have a contamination inside this area, even this area, it's an agricultural one, we can use the guideline for agricultural soil, because we are inside the buffer of 30 meters. Then we have to use the residential one. The guideline for residential one is more sensitive, and the concentrations are smaller. Okay. Now we are going to do the buffer for the flood zone. In this case, it's a very interesting one, because, for example, protection of groundwater for wildlife watering, it's applicable under natural and agricultural land use, but may be excluded at Tier 2 if no surface water bodies are present within 300 meters down gradient of the site. Okay, then it's a very interesting buffer, because if the age of the contamination it's not inside that 300 meter buffer, we can exclude it, this pathway on the Tier 2. Okay, let's go to do it. Again, vector, geoprocessing tools, fixed distance buffer. Now our layer for input layer is going to be the float, as we did here, is this shapefile. Distance is going to be 300 meters. Segment is going to be the same. Run. Now we have the buffer there. Okay, that is the float area, and this is the buffer, 300 meters buffer. Let's go to calculate, for example, from here to here. As you can see there, that's 300 meters. Okay, close. I'm going to click here, and now what happens here? Okay, I'm going to read a little bit the Tier 2. Protection of groundwater for wildlife. Ingestion of water by wildlife is considered an operative pathway under the natural areas and agricultural land use, and must be considered when there are surface water bodies within 300 meters of the site. If the direction of groundwater flows has been reliably determined by site-specific groundwater monitoring, this may be limited to 100 meters up gradient and 300 down gradient of the site. It means, for example, if you know what is the direction of the groundwater, for example, if you know the groundwater goes in this direction from the southeast to the northwest, for example, you can assume a buffer of 100 meters. Okay, but if the direction of the groundwater it's in opposite, I mean from the northwest to the southeast to the river, for example, in this case, that one has to be 300 meters buffer. Okay, because it's down gradient. Okay, I'm going to keep reading. The 300 meters radius is measured from the closest point of the zone of contamination to the closest point of the flow risk area. 1 in 100 years float area. Okay, that's our cartography. It's 1 every 100 years. Okay, that's the highest point of the float. And the use of the 300 meters offset distance is subject to the same restrictions as specified for the protection of aquatic life. Namely, the user must assess the following prior to applying the offset limits. Okay, in order to apply, if you want to exclude it, this is a scenario. Okay, first of all, you have to make sure about these three things I'm going to read now. Okay, one, the dissolved contaminant plumb is stable or decreasing, and the offset distance does not have the potential to change with the time. It means you have a contaminated plumb, then that contaminated plumb has to be stable, okay? And you have to make sure this plumb is not moving, okay? And it's not going to move in the time, okay? It's going to be stable. Then the second point, where the contaminant is a conservative solute that has little interaction with the soil or geological matrix and has low biodegradation potential, the potential risk for impact to the water body below 300 meters must be assessed and demonstrated through modeling of monitoring before applying the default distance. Okay, we have some contaminants. Okay, there used to be synthetic ones that it's a very difficult to be assimilated by the microorganism, for example, for a biodegradation, and you have to make sure these contaminants that are not going to be absorbed by the medium is going to move in. Okay, also the last one, it's about the Darcy velocity. The Darcy velocity is not greater than the FAO for coarse soils 3 multiplied by 10 to the power of -7 meters per second, where the Darcy velocity is greater than that of the default. The user must be able to establish an offset distance that is equally protective. Okay, in areas where the soil permeability, I mean the hydraulic conductivity, it's really high, you know, the contaminant, it's very easy to move with the water, you know. Then you have to establish a better buffer to make sure it's not going to be the contaminant is not going to move to the river, right? Okay, that's a very good example, because you know in tier 1 they use as the default 10 meters buffer. Okay, then the concentrations for the guidelines in tier 1 are very small, right? Because the X scenario, it's very conservative, it's very restrictive, right? But in most cases you don't have a river, okay, and you can eliminate this scenario. Even if you have a river, sometimes you can eliminate the scenario, and the guideline, the concentrations can be adjusted for more real scenario. Now we are going to add groundwater wells. For that one, we are going to add a layer from Web Map Service. Okay, we are going to talk about this kind of tools at the future, but at the moment I'm going to add just a layer because I'm interested, because I want to do a buffer for the groundwater walls in this area. Okay, then click here, add WMS. This is a web map service. A web map service, according to Wikipedia, it's a standard protocol for serving over the internet georeferenced maps image which a map server generates using data from a GIS database. Okay, then click here in new. I'm going to put here on water Alberta. Then you have to paste here the URL. I copy already. Then OK. And now connect. Okay, in this WebMar service we have different kind of maps. We are going to use this one. Okay, then let's go to add. Okay, as you can see there, that's the walls. I'm going to apply some transparency to this layer. Okay, as you can see, we have a couple of walls, one there and one there. Okay, if you go to Google, for example, and here in Groundwater, Alberta, there is an application. You can see the map for the groundwater walls here in Alberta. Has to be over here, but I'm not sure where. No, it's not this one. Oh. Yes, it's this one. The area we are working. Let's go to remove this one. Let's go to change the satellite picture. We are working in this area. As you can see here, there are a couple of walls. That's our walls. Okay. Now we are going to do is create a new layer. Create layer. It's going to be Shapefile, and it's going to be point. Okay. Then the coordinates is this one. Okay. Name is going to be water walls. The rest is okay. Water walls. Save. And now we are going to edit this layer, and we are going to add a couple of points here. Here, click in Add Features. It's going to be this one here. One click. Number one. Okay. And the second one is going to be this one. Click here. Number two. Okay. Then finish the edition and save. Close. Now we have the points we created there. One there and one there. We can remove this layer, and we have already the water walls for a shapefile. As you can see here, I would like to put for this one, if you click here, I would like to see the information for this one. You can see here is domestic. Okay, I would like to keep that one in my attribute table. For the other one, maybe we have to do more zoom. There we go. For this one, we don't have information. Okay, Then add the attribute tables for this one. As we said, the number 1 is domestic. Then open attribute table, edit, add a new field. Is going to be, they say here, while use, okay. While use is going to be a text. It's going to be 80 characters, okay. For the first one, we are going to put domestic. For the second one, unknown. Finish edition. Save, yes. Okay. Now we are going to do the same. You can change the type of. You can make a star, whatever you want. This one. Then change the color for a blue one. You can make bigger. Apply. Okay, now we have the couple of wells we have there. Then we are going to apply a buffer for both of them. Then go vector, Geoprocesing tools, fixed distance buffer is going to be the water walls. We are going to create a 50 meters buffer first, then we can create also a 100 meters. Segment 5 is okay. Run. Okay. Now we are going to create one for 100. Vector, Geoprocesing tools, fix distance buffer. Input layer is water walls. Distance 100 meters. Segment is good. Run. Okay. Now we are going to change the position. Even the walls at the top. There we go. That's it for the walls. In order to avoid to create a very long video, I'm going to stop this lesson here, and I'm going to create an extension for the lesson 6, where we are going to do all the composition for the final map. Okay, then if you want to see how I'm going to do that task, you can see the extension. Okay guys, thank you very much, and see you on next lesson.